Okay, so I guess what I'm doing is looking at that last section. And I wanted to remind you of something I wrote out last class. It basically is 4 steps, and it's a good sequence for solving equations that we're looking at. And so just as a reminder, this is something you should have in your notes if you have to do an equation. You want to simplify each side, which could be removing parentheses. It could be combining like terms where you had 3x and 2x and you called it 5x or something like that. There is another step here. Sometimes when there's fractions or decimals, we deal with it at the beginning. Once things are simplified, I haven't added that to our list. Once that's done, the second step is critical. We've got to get the letters on one side or the other. And so this little example, I had 5x and 3x. I targeted the smaller one, the one that was like lower on the number line. And I did whatever would take care of, get opposite of that. And so I did it to both sides and I put it underneath the like term so that then this side didn't have an x anymore. And then typically what follows it is a 2-step problem where we move the single number, the number that's added or subtracted from the x, which could be another letter, but let's say x. And that's done first. And then you're down to 1 step and you do whatever is the opposite of what's left. And it could be almost anything, but you do the opposite. So some problems need all of this. Let me see if I can find one. 3y plus 5 is 9y plus 8. Now, according to our list, the first thing would be to simplify. But the truth is, both sides are as simple as possible. 2 terms on each side. And so you skip over step 1 and look to step 2. And oh my goodness, we have 3y on the left and 9y on the right. And so what you want to do is get them to one side or the other. And I would take the smaller one out of habit. There's good reason for it. It avoids negatives. Take the smaller one, which would be 3y, and remove it. And because there's no sign here, I take it as positive. So I would subtract 3y on both sides. And that takes care of that. I'm left with 5 equals, this would be 9y, take away 3y, that would be 6y. And then it's plus 8. Now, last time I talked about students that had learned that the letter belongs on the left side, and you could take this and pivot it at this point in time if this bothers you, not having the variable on the left. But if it doesn't bother you, then we're down to the 2-step problem, getting rid of the 6 and the 8. Which one goes first?
The 8.
8 it is, the single number. So it's plus 8, so I'm going to subtract 8 there and subtract 8 on the other side. And I make sure I say that. On this side, the left side, 5 take away 8. We're in the negative zone here. And
-3.
-3. On this side, we had removed that, and so you can get rid of it if you want to. I don't know if you want to cross things out, but I kind of like it. And then this is 6y, which is left. This is where the action is. We're trying to get the y alone. The y is multiplied with 6, so therefore what I have to do is the opposite of multiply, which is divide. So I divide this side by 6 and I divide this side by 6. So now I have y equals. Now don't panic here. This is just a fraction. And 3/6 is 1/2. And one negative in the division makes it negative. And so y equals -1/2. You can write it either way. I prefer putting my negative in the numerator. Sometimes they'll do it like that. And honestly, if I'm tired, I almost don't see the distinction between the negative and the fraction line. And this is a visual thing. I kind of like it where I can see it. You know, what can I say? But there is an advantage to it. And so that's what I would like. Any question about that one? So it used almost all the steps. We didn't have to simplify, but we had all the other steps involved with this problem. Anything?
Can we do a similar problem that I just couldn't get an answer to, please?
Oh, certainly, got it.
Yeah, it's
Yep.
negative and then parentheses x minus 7.
Oh, I understand it. Got it.
Plus 2x
Mm-hmm.
minus 6 equals 4.
Equals 4. Okay.
Yes.
So if you recall, the very first step was to simplify, and this left side is a mess.
Yeah.
And so I'm called my attention right to here to get rid of the parentheses. And this negative in front of the parentheses is basically going to switch the signs of these two. You could also think of it, I'm going to write it above, as a -1 that's multiplied. This is how you could see it or think of it. The
Yeah.
negative in front could be like a -1 multiplier. And so a -1 times x would be -x. And here's where the rub is. This is, if I was looking for an error, I'd look for it next. A -1 times a -7 minus would be,
It'd be 7.
and I want to say +7 because it's a separate term. And you could have still done it without the 1 in there. Another way to look at this with the negative in front is it's the opposite of every single thing in the parentheses. So it's switching the plus x to negative, and it's switching the -7 to +7. That's basically calling for opposites here. And it starts at the parentheses and ends at the parentheses. So that's another way to look at it. But notice the x became negative and the 7 became positive. This is where the mistake would be made. I don't think it would be made later on. But let's finish. So then it's plus 2x and then minus 6. Okay, so at least we got rid of the parentheses. Now I've got 1, 2, 3, 4 terms on the left, and my job is to get the left as simple as possible. So I see a -x, which is also -1x, and a plus 2x, and I need to combine that. So it's basically 2x minus x, right? And so a plus 2 and a -1 would just be 1x. 2 take away 1 is 1. And I could just say x. Or I could say 1x, I don't care. But then I've got 2 single numbers, which also need to be combined. And the 7 and the -6 or subtract 6 is 1. And I need to put a sign there and say +1. Because these are not like terms. And so I added my x's together and I added my numbers together. Now you could rewrite it any way you like, but that's what you end up having to do. At this point in time, I'm going to copy the 4 over there, and we're down to 1 step. You find the side with the letter, which is here. You find the number that's connected to it, and it's a +1. So the only thing left to do, it's not always divide, it's whatever it needs to do to get rid of this. And so it would be subtract 1, subtract 1. +1 minus 1 is 0. X plus 0 is X. And over here, we're talking 3. So the real work, I think this was the difficult part, Mario, was that it?
Yeah, that was very confusing.
If I was betting money, I'd bet it on that sign. Right?
Thank you. Yeah.
Right? Was that it?
Yeah, that was the problem.
I know where to find errors. So that's where people would make a mistake. Okay. Anybody find another problem similar or that they want me to do? Okay.
See, oh no, that's good.
Got another one? Got another one here?
Yes, yeah. Let's see. So this one would be 2x plus 6
Okay.
minus x equals 5.
Okay. So this is similar in the fact we have now 1, 2, 3 terms on the left, and 2 of them happen to be like.
Yes.
Very much like the last problem. So it's 2x minus x. If you need to slip a 1 in there to reason it out, it's really 2x minus 1x. This 1 is understood. And you can use it or not use it depending. But 2 take away 1 is 1x. And so those 2 together made x. And so in a lot of ways, you want to get used to just saying x, but knowing it means 1x.
Yes.
And then the +6 is separate. And that's got to equal 5. We are down to 1 step. And the 1 step is to somehow find a way to get rid of that +6. And so the opposite
is, yes.
Subtract, subtract. And so the +6 and the subtract or -6 is 0. And so we're left with our x, which is what we wanted. Over here, we've got to deal with this. We had 5, we subtracted 6, we're in the negative zone. Right?
Right. So that'd be -1.
Exactly. How do you like it? So
that's good. I got a 2 for some reason. So.
I don't know. So the thing I want you to do, remember here, although the book hasn't used it yet, are there 1, 2, 3 terms. And I want to keep saying this. When you're multiplying, you're on the same term. But as soon as you go to add or subtract, you go to the next term. So this is, I see that one, and that one. This goes together. 2x is one thing. 6 is one thing. Subtract x is one thing. And so the x terms, the first one and the last one, could go together, and we put them together because that was our first step to make things as simple as we could.
Thank you. Thank you. Perfect.
Got it? Okie dokie. Honestly, all right. Well, I want to slip this in because once in a while we run into an equation with decimals. And there's a couple of things we could do. This is just going to take 1 step to solve this. And the 1 step will be to get rid of the 0.5. And so one option, since it's multiplied to x, one option is to just plain divide. And don't divide by the x, because then you're throwing out what you really wanted to keep. This is what you wanted to keep. So you want to get rid of the 0.5, and you'd have to do it to both sides. These 2 will cancel down to 1, and 1x is just x. And then at this point in time, you would have to divide this out using some long division. The 1 negative and the 1 positive in division we'll make the answer negative. And so I don't have to worry about that. I just need to remember it's negative. And then this would have to be divided. And so 0.08. So the 0.5 is on the outside. And if you remember from the chapter on division with decimals, this had to move over one place, which is multiplying by 10. And this had to move over one place. And at that point in time, you bring it up. So this is really a 5. And we're going to divide 5. And so if that's too messy for you, rewrite it. 5 into, what is it? What's left is 0.8. And this came up. So 5 doesn't go into 0, but it does go into 8 one time. And this is 5. And when I subtract, it's 3. Let me try to move that a little bit. If I'd add one more 0, I would have 5 into 30 is 6. And this is 30. And then there's 0 remainder here. So my answer was decimal point 16, 0.16. And so that was what had to be done. Now, I know there are people that are not so happy with doing this division. And let me find a different, well, that's probably good enough. I'm going to find another one and try a different approach. There is another possibility, is to clear the decimals. And I just wanted to bring this up. I think I saw it once or twice, they showed doing this way. If instead of being 0.02, if it was 2, that would be so much better. And so one approach would say, darn, I hate decimals. And so if you figure out that multiplying by 100 would clear this decimal and multiplying by 100 would clear that decimal, then what we could do is do that and get rid of the decimals. So when you multiply by 100, this would come over 2 places. So this would be negative 2x. And multiplying this by 100 would bring it over 2 places, and it would now be 36. Now, I don't know about you, but I like the look of this one 100% better than I like the look of that. So multiplying, and of course it took 2 decimal places in both cases. So I would multiply by 100, which is 2 decimal places. And now I think the problem is not as bad as it was. And I'm likely not to mess up. The only thing that would have to happen here is I need to divide by 2, but also by the negative. Remember that from last class. So you divide by -2 on the left and -2 on the right. Because a negative divided by a negative is a positive 1, and 1x is x. And then this is not too bad. 2 into 36 is 18. But with one of the numbers negative, the result is negative. So I just wanted to show that as one possibility. And let me take the previous problem and show you how that would boil down. 0.5x equals negative 0.08. This was the problem I did, and I did it with long division. This one will clear with only 1 decimal shift, which is multiplying by 10. But this one requires 2 decimal places, which is multiplying by 100. You can't do one way and one the other. So you're going to have to do it so that they both will clear their decimals. So my decision is to multiply by 100. On both sides. Now, multiplying decimals by 10 and 100 and 1,000 is nothing more than a decimal shift. So 0.5x would be 1, 2. So it would be end up being 50. 1, 2, 50x. This one here, the negative's not going to go away, but multiplying by 100 is 1, 2. So this is 8, right? 0.0812 multiplying by 100
Yes.
would be 8. And so you would divide both sides by 50. And you're going to have to sort this out depending on what they want. If they wanted, if they didn't specify what they wanted, you could reduce this into by 2. That would be what? -4/25. That would be an acceptable answer. The other thing you could do is turn it into a decimal. If they said, you know, they wanted it as a decimal. And so you would end up dividing this out, but I think the job would be a lot easier. And I don't know if somebody's thinking along these lines. But 50 goes beautifully into 100. And when you double this and double that, 16 over 100 is 0.16. And it still has a negative sign. So all this finagling that I've just done may or may not appeal to you, but it might appeal to some. And so when decimals become a problem, removing them might be a good thing to do, making the problem simpler. On the other hand, we could have taken 8 over 50 and divided it out. And it would have come out 0.16, just like before, and there's still a negative involved. So I just wanted to suggest a couple of options here. You may not be to the point where you want to finagle. I guess that's a good word. But you might, you know, but if not, then stick to the straight. Let's not be too creative, right? And so I know how it works. You're not too creative at first, and then after a while, you'll do so many of these problems that you say, oh, geez, I can see a good thing I might do. And so I just want to suggest a couple of possibilities. Has anybody gone over to the homework? I don't know. Let me show you one more with a decimal. See this one? Look at that. It is loaded with decimals, isn't it? Decimal, decimal, everywhere you look is a decimal. Now, you could still do this without getting rid of the decimals, but notice every one, it would be one decimal place and you would be out of the decimals. And so this one is sort of calling me to multiply both sides by 10. And when you multiply every single number by 10, 1.8 becomes 18x, 0.7 becomes plus 7, 1.1 multiplied by 10 becomes 11x, and multiply this by 10 and it becomes 14. If this appeals to you more than this, I think it was worth the effort. What do you think?
That's good.
Now, this one, each side is as simple as possible. You have two terms, an x term and a plain number. X term plain number. But I've got X's on both sides, so it's really clear that the 11 is the smaller of the two. So what I'm going to do is subtract 11X, that side, and run over here. Do you remember, did you see me running? Run, 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 run. 11X. I swear I've seen people do it on one side and then it's like they took a coffee break and then they forgot to do it on the other side. So what I'm saying is don't give it any time to mess up. Do it on both sides, the same exact thing, even with a minus. And so 18 take away 11 is 7X plus 7. And on this side, we actually took that out, but I'm still left with the negative 14. So copy the 14, but don't forget it had a sign with it. So try to remember that this problem was forget that it was a mess to begin with. In fact, you could hide it if you need to, but we're only looking here. This is a two-step. Which one goes first? And don't say 7. It's this one, isn't it?
Really?
It's got to be a 7. I'm just fooling with you. So
You're just making sure we're paying attention.
Wake up, wake up. It's this 7, right? The single number 7. And so I have to subtract 7 here and subtract 7 here. That makes that hit the dust. And this is left with what? 7X? And here we're getting better at this, right?
Mhm.
We're negative and then we're more negative. Negative 14 and then another negative 7. How much is that?
Negative 21.
Negative 21. And we're happy with that. We're down to one step. Thank goodness. This is multiply. Let's divide. 7 over 7 is 1. 1x is x. 1 negative in division is negative. 7 into 21 is 3. We're talking negative 3. Okay? I did this problem because I saw how getting rid of the decimals would make much more sense to me. And so I think in this case, it was, slam dunk. It was so obvious to me that that would have made it easier to finish the problem. And I think it was worth the time. Don't you? So you're not tripping over negatives. Now maybe, or decimals rather. Did it make sense to you? Yeah.
Yes, perfect.
I think so. Okay. So has anybody in the meanwhile come up with anything? It's if not, I'm going over to the homework. Speak now. Okay, there we go. Come on. Oh, it's like slow today. There we are. Okay. So here's the final, believe it or not. It's scheduled to open at 8 o'clock on Tuesday. If somebody's watching this tape, I know there's one person that can't take it at that time. They're going to have to contact me and we'll work something out. But I have it, there's no late passes on this. So they just need to contact me. Right now, I have 22 questions. The last question is extra credit. And it's just something I talked about at one point in time. And I'm just curious to see if you remembered it. And then I'll probably throw out one question if need be, if it turns out that somebody or everybody had a lot of trouble with one particular question. So you'll write out your work. And so I'm very interested in that so that there's extra credit. And you don't have to use a pen, but sometimes a pencil on a certain paper it's very, very hard to see. So try to make it so that I can clearly see it and then take a picture. You've probably seen this course evaluations. They should have come to you in the mail. And you have until the 17th, I think, to fill them out. So we're encouraging you to do that. Let's see what else. Let's look at the calendar. Here we are. So this is where we are. And I'll talk about that in a minute. I think we should have class on Monday to do one final review, and then we'll have Tuesday. This is actually finals week. If anybody has a conflict, let me know. But I will record the class. And so, yeah, I think one more class would be good and for review. We've actually covered all the topics. Let's see.
Thank you, Ms. Patterson.
Oh, you're welcome. I tell you what I did last class. We talked about this review and test review for each one. And what I did was I erased the old work so you'd have fresh problems without answers. And so this, I think, is your best plan for getting ready for the final. I want to tell you the following. The hardest problems do not make it to the final. So people worry about this. The fact that I've been a teacher and a student over the decades, I understand how people make finals, and I understand being a student. And so there's no point in asking the worst problem out there. So the problems tend to be middle of the road. So if you're worried about the worst problems, I'd say forget it. And
You're a saint.
do you hear what I'm saying? I didn't hear what you said.
You're a saint. You
Oh,
streets and
Yeah.
schools need to be named after you, Ms. Patterson. Thank you so much.
It's the way people do things, because otherwise things go crazy. And so I don't know, there's got to be the world's worst problem, but probably not in chapter 1. But that's what I want you to be aware of. What was the basic part of the chapter that seemed important? Here's a good one. I mean, we did this lots of times. The area of a rectangle, width and length. See, I mean, that's something we did multiple times. Division, let's see if I can find something else. This is probably not the best chapter to work on. Let me go back and get something else. But you know, when you're working through these, I think this is what you should do, is go through these review things. And if you find out, you know, oh, I know chapter 1 already, then go to another chapter. And I know some people have had more trouble with fractions. So this is chapter 3. And the thing to remember about fractions is that if you add and subtract, you must have common denominators. Can anybody tell me what the common denominator is for this one?
40.
40 it is. And so the book tends to write the problems horizontally, and I tried to write them vertically, but I would make it 40 for both. And then that would be a good one. So there's a good question. Let me just find some more. Adding mixed numbers was so funny. What somebody did this recently. They figured out how to add all the fractions and forgot to add the whole numbers. 1 and 3 and 1. That was part of the problem. So I guess what you just need to do is go through these problems and do it. Let me see. Yeah. These are kind of strange. Okay. All righty. Well, that would be nice. Why is this so nice?
Common denominator.
Common denominator. So the answer is 14 over 18. Will you get it right if you put in 14 over 18?
Yes.
No.
Nope.
No. How come?
Because you can simplify it.
It's always assumed that you would take a fraction 14 over 18 and reduce it to 7 over 8. Right? And so,
By 2. Mhm.
yeah, divide by 2. Right. And so that was that. This is not the world's best problem, but this is one thing that we worked on several times, is the distributive property. Instead of adding 1/5 and 1/8, which would require a common denominator, you could just distribute. 40 times a fifth would cancel, and 40 times an eighth would cancel. So that might be another choice for you. Does that make sense? Because 5 goes into 40 and 8 goes into 40. So you could literally do it that way. There's probably 2 ways. But that's what I suggest that you work on. The one thing I did notice is that there was no review for chapter 11. Let me go back and check it out. Let's see, we had a review 6 and 8, 5 and 10, 3 and 4. I didn't see one for chapter 11, which is the chapter we just did. My suggestion would be to look again at the homework of chapter 11. And this is what we were just doing. This was the prep work for solving the equations, where you had like terms and you would combine them. And then you had plain numbers and you would combine those. And so that was chapter 11. Let me see what else was in chapter 11. Oh, here's a good one. I'll tell you this right now. 7a plus 2, let's do that one. 7a plus 2, and they said a is -4, right?
Yeah. Negative.
All right. Let's make sure you remember this one. So this basically said find the value, but then they told you the value for a is 4, and they want you to simplify this. This is where I wanted you to use parentheses. So instead of a, I put parentheses -4, and then I said I copied the rest of the problem as it is. And once you have the number in place of the letter, this is reminding you that it's multiply. This would have reminded you that it's multiply. So 7 times -4 plus times minus.
So it's -27.
Yeah, it's -20.
28.
Mhm. This is an even number, so this must be even. And then you add 2. And so now you're -28, but when you went up 2, so you got closer to 0, but not that much. What's your answer?
-26.
There you go. How's that? Okay, so I wanted to remind you of that. Let me see what else while we have time. Let's see if I can't get to the end of this chapter. Oh my. Okay. Here we go. Okay. This is 11, and so this is what we've worked on, and we haven't been tested, so we need to. 4b minus 1 subtract b subtract 3. So the instructions here would be simplify and count them 1, 2, 3, 4 terms. You have to put the b terms together and the single numbers together. So we're talking 4b, and notice this is a minus b, that sign goes with it. How much is that?
3B.
3b. And then as far as the numbers go, I've got -1, and then I've got a -3. How much is that?
-4.
-4. So when I put this all together, I've got 3b minus 4. How's that?
That's good.
That's good. All righty. Then in chapter 11, we started solving equations. This is a one-step equation. I'm going to work my way through these. What do I do next?
Take away the, just like take away the 7.
Okay, let's take it away. How do I do it?
Add 7 to both sides.
Add 7, add 7. That takes care of that. I'm left with just plain x. And what I have to do is combine these. I've got a +7 and a subtract 3, or 7 minus 3. Answer?
+4.
+4 it is. Okay. Here's another one. 3x subtract 7 is.
Whoa, question.
Uh-huh.
Now, we did the 7 because
Ah,
the
okay.
answer was -3. Is that right?
I want us to look at the original problem, which is this.
X minus 7 equals -3.
When you're looking at the first time you look at a problem, you kind of like scan it through, and then you say, where are the X's, or where are the letters?
Okay.
The letters are over here on the left.
Oh, that's right.
Once
the
you figure
letters.
that out, you want to keep the X and get rid of the subtract 7.
Okay, yeah.
So whichever side has the letter is where your focus is, and you have to say, I'm not getting rid of the X, that's what I want to keep, right? So I get rid of the 7, which is -7, I added 7. So,
Okay, okay.
now let's look at this baby.
Thank you.
Good job. So I scan this problem, and then I say, oh darn, I've got X's on both sides. Now, each side is as simple as I can get it. So that's not my problem. So now my next problem, step 2, of course, is to say, how could I get the letters on one side or the other? And I don't care which side it's on, just as long as they're not on both sides. So I've got the 3x over here and the 5x over here. According to what I typically do, which one would I go after?
The
The
smallest number.
smaller variable.
Smaller one. And what that does is avoid negatives, and negatives trip people up. And that's the only reason I'm doing that. So this is considered plus or positive because there's no negative to it. So I have got to do -3x or subtract 3x, and I'm doing it right under the x's. That takes that out. I'm going to simplify this. I'm left with my -7. 5x take away 3x is just 2x, and then I have to add 1. Now notice when I did that, my x is now on the right side. Do I care? Not usually. One person didn't like it over here, and so you could bring your 2x plus 1 here and your -7 there, and that's it. But this is fine. So now my focus is over on this side. I've got the 2 and the 1. That's the 2-step problem. Which one goes first?
1.
1. It's a +1, so I would then subtract 1 or -1, however you want to say it. -7, -1. How much?
-8.
-8 it is, exactly. And this hit the dust, and I'm left with
2x.
2x. My focus is always on the side with the X, and I'm done with its only X. But it's not done yet because it's got a 2 there, multiplied to the X, opposite.
2.
Divide by 2 each side.
Absolutely. Cancel, cancel. 1x is x equals
-4.
1 negative is negative in division. That's your answer. -4 is x is -4, whatever. Okay. Here's our next baby. 2 times x minus 5 is -8. I would say this qualifies as simplify. That first step. See, the parentheses are enclosed inside the parentheses. So the truth is we can't even get to it until
So you
we
have to distribute it
liberate
properly.
it. Let's liberate it. So what are we going to distribute? Exactly. So tell me, what's your right?
2x
Uh-huh.
and then negative, and then 2 times -5 is -10.
Okay.
So 2x minus 10 equals -8.
Yep. So we liberated the x. It's now freestanding. See, it was sort of like, in a way, blocked. And so we had to let it out. And then what's next? Here's my focus side.
Add
Getting-
+10.
Yeah, got it. Add 10, add 10. I'm left with 2x. And now, let's just be careful here because people make mistakes. -8 plus 10 is the same as 10 plus -8. Answer?
2.
Correct. Are we done yet?
No.
No, we're not there yet. This is multiply, divide, divide. You will do this before you even, you will do that division step before you even realize you've done it. In other words, you'll be so good at this, you won't know who you are. X equals
1.
what did you
1.
say? You're going to be so good at this. Oh. All right, let me see if I got anything else. All right. Here's one with a decimal, and I know I made a fuss about decimals, but let's take a peek at this problem. It's letter A, but who cares, right? We don't care about letters. They're really numbers anyway. But this, if we could get this alone, we would have the answer, wouldn't we? And so before, I would multiply by 10 or 100 or something. But you know what? I want to leave that A just the way it is. And so I think I might just keep the decimals. What would I do first? If I kept the decimals?
Move them, move them. Move them
If you,
And how do I move it? In what
to
way?
the left, to the right.
I'm going to move it, but what do I do mathematically?
Multiply 10 by both sides.
No, I don't even want to multiply this time. I'm going to show you it. Sometimes you don't need to multiply.
Just subtract.
I'm just gonna
Subtract
subtract.
3.7.
Uh-huh. See, that's not a big deal. I mean, if I put it right underneath it, it's ready to subtract. And the reason I didn't bother is because this was already A. So multiplying by 10, I would have had to multiply this by 10 as well. And so I said, let's just, it's not a big deal. I'm going to just subtract. Think of this as money. 8 take 1, 9 take away 3 is 6. I think I wasn't bad about keeping the decimals that time.
No,
You know, and it was what made up my mind was that these were nice decimals, as decimals go, and then this was already the letter I wanted, and so I didn't want to foul it up and change it, so I just decided to move the 3.7 to the other side, just be done with it. you see that? So multiplying by 10 isn't always the
Oh,
case,
oops.
but it could have been. Okay,
Yeah, it's just longer if you do the multiplication by 10 and you might forget to put the 10 in front of A like I did.
I know. And so, but you know, I'm sure I had another problem. I'll make up one, which we're not going to do. But if I had a problem like this, 1.2a plus 0.5 equals 0.9 or something like that. In this particular case, the a is not all by itself. It's got a decimal, and this is a decimal, and this has a decimal. Here's the time where I'd multiply by 10. I could just like wipe out all those decimals. You see what I mean? This time it made sense to do it, just to multiply by 10. That would give you 12a, and this is not a real problem. Okay? But see, that made it better for starters. Okay? So in that case, I think multiplying by 10 was a good plan. So this is what I hope. So we'll plan on having a class on Monday, and we'll just bring every question that gets you in trouble. And keep in mind those review chapters, the review things at the bottom of the XYZ homework website would be a really good place to work. And if you think you need to work on one chapter more than others, then focus there. But I'd kind of take a peek at most of the chapters. You could look at your homework again if you wanted to. That would be another thing to do. But try to think about what were the main topics. We did fractions, and we did decimals, and we did percents. We did a little geometry, and I would write out the formulas, the rectangle and the triangle and that kind of thing. And then we did the positive and negative numbers, right? And then finally, we just did a little bit of equations. And so there's the final, right? Just basic.
Sounds good.
Just basic problems. And we'll just see how it goes. But that's our plan. And so in the meanwhile, I'd like you to finish this homework.
I have a question. I'm sorry.
I'm tutoring people left and right. And so if you need help, let me know. I'm helping somebody finish today at noon, and I've been tutoring most days. So if you're in trouble, let me know. Okay?
Okay,
I do
thank
have
you.
a quick.
Okay, yep, go ahead.
Is there going to be a Zoom link for the final, or is this going to be different than?
I think we'll do Zoom.
Okay, cool.
Yeah, we'll just do it so that in case you get in trouble, you can talk to me. I gotta stop this.